So in this tutorial, you will learn how to create a simple FPS controller. You can jump around, look around, and move using only a rigid body, and the gravity is calculated for you. You don't have to do anything with that. You don't have to calculate the jump force, and it's pretty flexible in terms of what you can adjust and what you can't. So sit back and relax and enjoy the tutorial. So the first thing we want to do is to create a new project from the Unity app. I'm using Unity app version 3.5.1. I want to create a new project. 3D core is fine. I want to call this simple FPS. You can save it wherever you want. Now, after your project's been loaded in Unity, what you want to do is to go to the hierarchy, right click, and create a new empty game object. It really doesn't matter what you call this, but I'm just going to call this player. And inside the player, I'm going to create another empty game object. I'm going to call this head. Now simply drag your main camera under the head. And also make sure to reset its transform. Now this step is optional, but I like to keep things organized. So in the assets panel, I'm going to create a new folder and call it scripts. And on that folder, I'm going to create a new C# script. You can call this whatever you want, but I'm going to call this player movement controller. Now, if you double click on this script, it should open up Microsoft Visual Studio for you, unless you haven't set it on the external tools. If Microsoft Visual Studio doesn't open up for you, what you want to do is to go to the Edit, Preferences, External Tools, and select the IDE of your choice from here. Once inside Visual Studio, you're being represented with two methods. The first one is start, which is only called before the first frame, and the update is called every single frame. Now, in order to move the player, we need a direction that represents which way the player will be moving. And in code, we show that direction by a vector. And we use vector3 for that. Vector3 is just a class that holds three numbers, representing each x and y and z axis. So first thing I'm going to do is delete this comment, go up here and type private vector3 direction. And now in the update method, what we want to do is assign the direction to the input of the player. And the way we get the input of the player is by typing input.getAxis. Now you can think of getAxis as a number between -1 and +1, depending on the input of the player. So let's say if I press the A key on the keyboard, this will return -1. And if I press D, this should return +1. Now getAxis by itself, it kind of smoothens out the input of the player, and we don't want that. We kind of want the raw input. So we don't want it to smooth the transition between these values. So we use getAxis raw. And I'm gonna type horizontal. And if you want to know what buttons are horizontal, you can go back to Unity and edit project settings, and on the input manager, you can see there's a horizontal and a vertical axis. So on the horizontal axis, there's a negative button and a positive button, which is left and right. And left and right is basically just the left arrow and right arrow on your keyboard, but there's also another alternative button, which is A and D. So that's how it's going to calculate your input. So back on your code, you can see it's giving us an error, and that's because this getAxis raw method returns a float, and direction is a vector3. So we somehow need to convert this float into a vector3. And the way we do that is by typing new vector 3, and horizontal is just the x-axis of the direction we want to place. So we put it on the x-axis, and we don't want to move up and down. So we put 0 for y-axis, and for the so now we've converted the input of the player into a direction. Now with directions, you kind of want to always normalize them, because if you don't, then the player can move faster diagonally. So just type dot normalized. And now this makes sure that the player will always move the same speed at any direction. Now with this code alone, we haven't done anything because, well, we're just getting the direction that the player wants to move. We're not actually moving. And for that, I'm going to use a component built in Unity called a Rigidbody. And basically, this makes it easier for us to move the player. And things like jumping and everything is calculated for us. So we don't have to do anything in the code. And the way you access that Rigidbody is by typing private Rigidbody. You can call this whatever you want. I'm just going to call this RB. And you can get that Rigidbody in the start method by typing RB get component of type Rigidbody. And so now we have access to that Rigidbody component. And there's a member on that called velocity. And what you want to do is assign the velocity to the direction we want to go. Now there's one thing we need to do is to come up here and type public float player speed. Just gonna assign it to 5. And what you want to do is to multiply this direction by the speed that you want to go. So now if you go back to Unity, and I'm actually gonna increase the height of the head so we're above the ground. I'm gonna make it 1.8. That should be fine. And just so we can see where we're going, I'm gonna create a 3D object, a plane, so we can see what we're doing. I'm gonna scale this up a little bit. There you go. And also I'm just gonna add some cubes to the scene. Okay, so if you go to the game view mode, and if you press play, you can see we're falling through the ground. And that's because our player doesn't have a collider to collide with the ground. So it's just falling through the ground. So you want to go to your player and add a box collider to your player. And just going to bring it higher a little bit. And also make sure to attach your script to the player by simply just dragging it on the player. So if you play this, you can see if I move forward, I start to roll. And that's because you need to constrain the rotations of the player on the Rigidbody component by simply taking all the axes. And now if you play it again, you can see I can move around. And it doesn't matter which direction I move, I'm always moving at the same direction, even diagonally. So now we're done with the movement controller. Let's start with the camera controller so we can actually look around. And by that, I'd like to create a new script. You could totally put it on the same script, but I'd like to keep things separate. So I'm going to create a new C# script, call this camera controller, and open up in Visual Studio. Now, you want to attach the script to the head of the player, but we also need to reference the camera. So I'm going to create a public transform because we only need to access the transform of the camera. I'm going to call this underscore camera. And now if I go back to Unity, drag the script on the head, and you can see we have a camera slot. We can just drag the camera there, and now we have access to the camera. So there's also something else I want to add. public float camera sensitivity, and I'm gonna assign this something like 120. You really need to play with this value later. And on the update method, what you want to do is, well, first of all, let's rotate the head along the y-axis. So for that, we need the x position of the cursor. So the way you would access that is, there's a lot of way to do that. There's a new input system and the old one. For the simplicity's sake, for this video, I'm just gonna use the old one. I'm gonna create a new variable, call this mouse x. I'm gonna assign this to input dot get axis, this time mouse x. We need to do the same thing for the mouse y. Just gonna copy this, call this one mouse y. So if you think about it, we need the mouse x to rotate the head along the y-axis. So for that, you need to access the transform, and there's a method called rotate, and it expects a vector 3. So new vector 3, since we want to rotate this head on the y-axis, we don't want to do anything with x-axis, so just gonna type 0. For the y-axis, we need the mouse x, and multiply this by camera sensitivity. Finally, multiply this by time dot delta time, and 0 for the z-axis. Now, delta time is the time between the last frame and the next frame. So this makes sure that no matter the FPS you're getting, no matter the type of components you have in your PC, it's always going to run the same for all of the users. Now, if you go back to Unity, press play, you can see we can look around, but not up and down, and that's because we need to rotate the camera for that. So we could do the same thing for the camera as we did with the head. In fact, I'm going to show you that. I'm going to do the same thing, but this time on the x-axis. Because remember, we want to rotate the camera on the x-axis and the head on the y-axis. So now if we go back to Unity to see what this code has done, you can see it's actually working pretty good. The camera is inverted, but we can look around and this is kind of working. But if you look up and keep going up, you can see we can loop around ourselves. And that's just not how a human's neck works. The way we fix that is to add a limit. Going up here, private float, camera, x-axis limit. Instead of directly rotating the camera, we want to add to this variable. So we're essentially keeping the degrees we need to rotate the camera inside this variable. And we need to clamp this, and there's a method inside of the mathf library, and it's called clamp, and it takes the variable, the minimum, which is going to be negative 90 degrees and positive 90 degrees. So it will never let this variable go above or below this number. And so we can't just put this here, because if we do that, we're just going to keep rolling around. So we need a way to set the rotation instead of calling a method. And for that, we use local rotation. But the thing is, local rotation expects a quaternion. There's actually a method inside of the quaternion class called Euler, and this method expects normal degrees. So we could just put that here and 0 for the rest. So now if you go back to Unity, press play, You can see we can look around. If we keep going up, we can't go higher than 90 degrees because we kept it. And the same thing for scrolling down. So that's basically it. But if I move forward, you can see there's no problem. But if I look right and press forward, I'm still moving the same direction. And that's because on our player movement controller, we're not giving it any information to which direction to go. We're just using the input keys. But we kind of need the rotation of the head to know which direction to do. And for that, we need a reference to head. And so for that, you need to write public transform head. And what I'm actually going to do is to delete all of this. Instead, I'm going to multiply this horizontal axis with the head's right transform. So what we also need to do is to add this with the vertical axis of the player, multiply this by head.forward. And finally, you want to normalize this whole thing. So you want to come here and type normalized. So now if you go back to Unity, also don't forget to assign the head to the player movement controller script. And now if you press play, you can see wherever I look, I'm always moving towards that direction just by holding forward. And I can move right and left. But if I look up, I won't go up. And that's because we are using the head's direction and not the camera's direction. Because if we did that, then we could also go up and down. And we don't want that. And we're almost done with our controller. And the only thing we need to add now is the jump functionality. And for that, there's a lot of way of doing it. But I'm just going to check a box basically at the feet of the player. And if they're touching a ground, then we can jump. And for that, what you want to do is to go to your player movement controller script, come to the update method, and we want to check for the player jump input, which is going to be get button down, and it's called jump. And if you want to figure out what this jump button is, you could go to the input manager and check for the jump axis. And in this case, it's going to be the space key. And what we want to do is to create a new method called is touching ground. And we will be making this method in a second. And basically, if we are pressing the jump button and we are on the ground, we want to jump. And for jumping, it's very simple. We just need to say rb.velocity plus equals, and we need a jump force variable. So just gonna call this public float jump force, maybe like 4, and jump force. And you could say new vector 3 and then put the jump force on the y-axis. But there's actually another way, and that's much shorter, and that's just multiplying this by vector 3 dot up. And now let's make this method. This is going to return a boolean. And basically all this is going to do is, in the physics class, there's a method called checkbox, and it's basically gonna create a box at the origin of the player, and it's gonna check if it's overlapping with other colliders. So it's gonna be transform.position, the position of our player, the size of it, which I'm basically gonna go for 0.05. So it's gonna be a really small box. You could increase this value later. It really depends. For orientation, simply type quaternion identity. And for layer mask, we need the layer mask of the ground. So just call this ground layer. Yeah, and we need to create this variable up here, public layer mask ground layer, and we need to assign this later on the Unity editor. And we need to return this value. So basically, if we are touching the ground, it's going to return true. If we are not touching ground, it's going to return false. If you go back to Unity, on the player, you can see there's a new slot called ground layer. Now, at the moment, we haven't created a ground layer. Click on the plane, and on the layer, add a layer. Simply just call it ground, and then assign it to ground. And on the player, select the ground. Now, if you played this, you can see if I press space, it doesn't really do anything. And the reason for that is up here, we're kind of overriding the velocity here. And that means we are messing with the y-axis of the velocity. So we're basically just setting it to 0 each frame. So we really don't have a velocity on the y-axis. So what we want to do is to add the rb.velocity.y, but this can be completed because we are adding a float to a vector3. So we need to convert this to a vector3 as well, and we're just going to multiply this by vector3.up. And so now if we go back to Unity, press play, you can see if I press jump, I can jump, and I can only jump once. So I'm going to increase the jump force and press play again. And I'm going to try to jump on one of these cubes. And if I try to jump on it, you can see I can still jump. And that's because we've also set the cubes to be ground layer. If you don't want to be able to jump on the cubes, you could change the layer of them. And also in the camera control script, on the start method, I'm gonna type cursor.lockState equals to cursor_lock_mode.lock. This is gonna make sure that we don't see the cursor when we play the game. And also, the camera is kind of inverted now, so we need to add a minus here so the camera is rotating the correct direction. So that's it everyone, thank you for watching this tutorial. If you liked it, please give it a thumbs up and subscribe to the channel for more videos and share the video with your friends. And until the next tutorial, see you later.